Hello everyone, good afternoon. And today we are going to introduce our 1064 nanometers Raman spectrometers to you. And in this today's live broadcast, we are going to introduce some advantages and application of the 1064 Raman spectrometers. This PPT is prepared by Fred Liu and translated by Freya Wang. So this series live broadcast, we are going to explain from the following 5 parts. Part 1 is the traditional existing problems of the 1064 of the Raman spectrometers. Part 2 is the advantage of the 1064 nanometers Raman spectrometers, and part 3 is the Optosky manufactures 1064 Raman spectrometers, and in part 4 we are going to introduce 1064 nanometers Raman spectrometers application, and in part 5 we will make a brief introduction of our company. First of all, we are going to introduce the Raman spectroscopy principle. This one is the Raman with India. With the Raman, he's called Raman. He's in year 1928, he discovered the Raman phenomenon, and everybody want to remember him, so named Raman. In 1930, he received the Nobel Prize. So, because the Raman discovered the Raman phenomenon, so we called named by the named Raman. And this is the principle of the Raman spectroscopy. And this is the Rayleigh scattering, and this is the Stokes lines, and this is the anti-Stokes lines. Because you can see, because due to the energy transfer, when Stokes line and anti-Stokes line happens, it has the energy levels transit. So for this, we can analyze the Stokes lines and anti-Stokes lines to analyze the Raman phenomenon. Here, we use the long pass filter to filter the Rayleigh scattering and the later Stokes lines to make analysis. Traditionally, Raman spectrometer is made up of a narrow line-wise laser and a Raman probe and the spectrometers. The lines shoot on the collimating lens and focus on the focus lens, and then shoot on the sample. The sample will generate scatter lines to refract it from this grating to these mirrors, and pass through long pass filters to accessing to the spectrometers to make analysis. So this is the traditional Raman spectrometers component. The most core component is the spectrometer, and the second one is the laser. The third one is the probe. So whatever the Raman spectrometer's housing looks like, and they are mainly composed of these 3 components. Secondly, we would like to introduce the Raman applications and core competition. Raman has mainly applied to 6 applications. However, not only these 6 industries, uh, Raman spectrometers was widely applied to pharmaceutical industries. It used to identify raw material and excipients, and also for drugs scan for inspections for QA/QC. And also very popular in the industry is public safety. It can use to detect the drugs and narcotic drugs, and detect toxic substances and explosive and flammable materials. And third one is widely used to gemstones. It can use to identify place of arranging of the germs, and it can use to identify anti-faking and antique identification. They are also used widely in biomedicine, like early detection of cancer and calculate analysis and bacterial protein and disease detection, etc. And also, they are also in food safety to detect the pesticides residues and the food additives and contaminants. It also used to detect refined gutter oil, which is notorious in China. And also, they are used in water quality contaminants analysis, petrol analysis, and deposit analysis. Raman spectrometers have so many applications. So Optosky is the China national standard drafters for the Raman spectrometers. We have the most full range of Raman spectrometer covered from 266 to 1064 to 1064 nanometers. Raman spectrometers. So, and we are also for 1064 nanometers, we have the exclusive Raman spectrometer manufacturer in China. And Optosky launched the first handheld Raman as early as 2016. And in the next year, we launched a dual-band Raman spectrometer. We are one of the two manufacturers in the world till now can manufacture a dual-band Raman spectrometer. And also this year, we are going to launch the three-band Raman spectrometer. We will make a breakthrough in the world. And also our Optosky performance is quite reliable, and we also have released a quantitative algorithm to make us Optosky as a very professional, as an expert in Raman spectrometers development. You can see that we can see that this is the alcoholic Raman signal. It has it's like distinctive shape. It has distinctive shape. However, beer, the main component is also alcoholic, but from the spectrum we cannot see any alcoholic signs. So why the alcoholic Raman signal is hidden? Oh, as we see that beer is a biological materials, so it have a very big fluorescence background. So these backgrounds could have interfered with the Raman signals. So we see that like a lotus just appears, just like a lotus just appeared one peak. So this is the very common problems that Raman spectrometer face. that is a high fluorescence, but Raman signal has hidden the Raman signal. Raman signal is interfered by the fluorescence background. This is the fluorescence, and the fluorescence signal is very intense. It's about millions of times stronger than Raman signal, and traditional Raman signals are easily interfered by the fluorescence. So we can see fluorescence signal is much higher than Raman signals. So there are many materials have high fluorescence, such as narcotics drug, heroin, and fentanyl, and explosives. Also, we have some biological samples have a high fluorescence like beers, and we have bacterial and pharmaceutical drugs also. About 20% pharmaceutical drugs have a fluorescence, and also have some fuel, petroleum, vegetable oils, and textiles, and plastics, and color samples. These color samples also have a high fluorescence background. So, whether in 7332 or 785, these two, the Raman signal is hidden by the fluorescence signal. But now we can introduce the 1064 nanometers Raman spectrometers. It can naturally resist fluorescence. Infrared photon has low energy and is seldom have been absorbed by molecules. So the ground state electron is difficult to be excited to generate fluorescence. So as a result of 1064 nanometers, Raman spectrometers can resist fluorescence background. So this big fluorescence had make the Raman signals very weak. After using the 1064, the red one, you see the shapes so distinctive, like the rotors can finally flowered. So the Raman signals finally appears with there, and also here is a peaks. And here in the 785 nanometers Raman, I don't have any peaks at all. So next we are going to introduce how to remove the fluorescence background. And as we know that there are many ways, there are several ways to remove the fluorescence background. Here we are mainly introduce three. We make a comparison of the three fluorescence analysis. First one is the baseline correction. Baseline correction has been integrated into our optoscoped Raman spectrometers. It just using algorithm can remove the fluorescence background, like this one. This is the fluorescence, and after remove by algorithm, we use algorithm to remove this fluorescence signal, and this is we can appears very nice Raman signals. So optoscope baseline corrections looks nice, and also we have, if we only have this signal, big fluorescence signals appears, and only signal peaks appears, can use the baseline corrections to export elegant Raman spectrum. Those in some areas do not have any peaks. if these have no any peaks after baseline correction, and the peaks will also lost. So it has some disadvantages also. Maybe this signal is very weak and dynamic range is very small. So we know that the advantages of baseline correction is it just use the algorithm to make calculation to detect the background fluorescence background. So it takes it's zero cost. However, the disadvantages is it can only those has the peaks where appears the peaks. Otherwise, if the peaks overlap by fluorescence, it will not have any peaks left. So it could cause the peak loss. And also we have mentioned signal intensity is weak and dynamic range is small. Next is the difference operation. Fluorescence background do not shift with the different excitation frequency. So we just by using adjacent wavelengths such as 784.5 nanometer and 785.5 nanometer to excite two samples to obtain two groups of the signals. By a difference operation left only Raman spectrum. These difference operations because the laser cost is not high, so its advantage is also is not cost high. However, like a baseline correction, it can also cause peak loss, and the resolution is low. And because after the difference operation, the noise become bigger, and also and also like this one, if this is like this one, if this shift is left is short and right is high, after baseline, after difference operation, the shifts could be look like this way. So it will make the curve shapes distorted and look not so nice. So it's the disadvantages. It will cause unevenly shift, and also it's after difference operations, it can cause the baseline is unstable and can even cause a shake in a mess. Now we have to introduce 1064 nanometer Raman spectrometer, which in nature mechanically can resist fluorescence. How can it resist fluorescence? Because it's 1064 nanometer is near infrared photon, cannot be absorbed. So the fluorescence cannot be generated. If it resists the fluorescence generation, it's excellent to remove fluorescence. It has so many other advantages, so why not everybody used 1064 nanometer Raman spectrometers? Because it also has some disadvantages. Firstly, it's a high cost. You can see that whatever 1064 nanometer Raman spectrometer is cost overall, it costs in the market price about 5,000. It's about 50,000 US dollar. Why? Because you need to use the India as a sensor. It had to cool down to minus 20 degrees to work on it, and also it can generates a large power consumptions. And 1064 nanometers has low frequencies, and so the detect time is longer. 785 is need only few seconds, but it takes 30 to 40 seconds to complete our test. Also, we have a time gain control methods too. to remove fluorescence. The principle is like this, because fluorescence will be appeared in nanoseconds, and the Raman signal will be appeared in microseconds. So here there's a very short time differences here. Time differences here. So here we can install a shutter to remove the fluorescence and left the Raman signal. So, but the cost is because the time is so short. The nanoseconds and microseconds. So the cost is at least 1 million RMB. So it's very, very expensive. And the fluorescence, and also we have to introduce another method. This is photo bleaching. Photo bleaching is also can remove the bad fluorescence, but it takes at least half an hour to photo bleaching to remove the fluorescence background. This we have already introduced before. So next we are going to introduce the AutoSky's 1064 nanometers Raman spectrometer series. We have altogether we have 7 models of the Raman spectrometers series. First is the ATR6600. This is the most popular handheld Raman spectrometers, and its performance is competitive with the portable one. And also we have a portable ATR Raman microscope and a portable ATR 3000 and ATR 3110 series. And also we have a dual band Raman spectrometer, also installed 1064 and the ATR 8000 dual band high throughput Raman spectrometers. And we have a Raman microscope. This one can be also installed dual band and 3-band. And next, we will introduce more specifically about our handheld 1064 Raman spectrometers. ATR 6600 is because the AutoSky is the exclusive manufacturer of this one to supply to China, and we have received CE certificate. We have the police certificate, and also this instrument has been nominated for the World Military Games for safety products. So, and also we can see the feature is 1064 can reduce fluorescence, and it also has advanced algorithm and can detect mixture, 3 mixture. And also we have the 5.5 inch touch screen, very good screen. And we have a camera here. We have a camera, it's a 13 mega camera, and it can scan barcode. And also it have a many multi modes like GPS, 4G, GSM, GPRS, Bluetooth, Wi-Fi. It can build self-built library, and it can export report in format of PDF, CSV, TXT, and the battery can run over 6 hours and maybe longer. Is 1 day's operation is no problem at all. And it also has lightweight, weighs 1.2 kilograms, and easy to take to anywhere. And it has the IP67. So we have so many features to make this ATR 6600 one of the most popular 1064 Raman spectrometers in the world. And not only we have so much winner award this year, we also received a winner award for this one. And they are applied mainly to the police narcotic drug identification, like China's heroin and fentanyl abuses. So it's very popular for many police stations. And also we have a pharmaceutical drug identifiers. We are 20 CFR 21 compliance, and we can provide IQ, PQ, OQ compliance. That is, it can dictate liquid, solid, powder, whatever materials, substance states it can dictate. And also we have an ATR 3300. It's an autofocus Raman microscope. And it's an autofocus Raman microscope. And this true focal, it can mapping. This is one is the exclusive miniature Raman microscope with mapping functions. We are the only miniature Raman spectrometers. And also, because it has 5 mega cameras, so the image is cleared. And also, we can have a 1064 many wavelengths options, including 1064, A30, 785, 630, and 532, and use USB 2.0 interface. It applies to many industries. And also, this is our poster for Raman microscope. We have so many wavelengths for your selections. And not to mention 1064. And also we have 3 types. We have the basic type. We manual focus, and we have an autofocus, and we have the mapping functions. And also, this is we have introduced the Raman signal 5 megahertz imaging and real-time focus can detect uneven samples. So it can real-time field for autofocus, even if it's uneven uneven sample, it can images. And it have a move ranges 50 to 50 millimeters. And we have a different objective lens for your selections. We have the high sensitivity Raman spectrometer, use the TE vaccine CCD inside. And also we have the high, because it has no moving parts, so it's quite reliable and no need calibration. It just need to calibrate a time per year, can save many times of the operator. And it also suited to various environments like lab, etc. And this is our newly developed human machine interface. This one is have a powerful functions we would like to introduce to you. Firstly, is the camera windows is here, and this is the pictures image spicing. It can spice image 50 to 50 millimeters, and this is the spectrum display, and you can click here to select spectrum, and it will show in this area. And also we have this is Raman image. It will show the mapping here, and if you click each one, will show the intensity differences. We can see if here intensity is stronger, so the concentration is thicker, and this is concentration is thinner. And also this area we can show the software is online or not. If the green indicates it's connected, if it's red, it's disconnected. And also have the data, raw data and spectrum data, deduct the dark current. And also we have the dark current data. And these areas we can display peaks, different peaks, intensity. And also we can show here material ID test results. So this human-machine interface functions can apply to more applications. So this is the ATR 8300 applied to cells. And you can see this is the spectrum by adding the cells. This is ATR 3064 portable Raman analyzer. It uses the Android system, and it has is used so the whole operations is very smooth, just like using cell phone. And also we have the bigger screen, 11.6-inch touch screen, and the resolution is 11 centimeters, and wavelength is 200 to 2600 centimeters. It has two-stage TEC cord, and excitation wavelength is optional. We have also 1064 here, and weighs only about 7 kilograms, and can bring with your car. It's very popular, especially in China, sold quite a lot. Portable 1064 nanometer Raman analyzer. We can see this is Crora ephedrine spectrum. You can see this one is used the 1064 Raman spectrometer. So the signal is very good. However, if you use 785, the signal is weaker. And also, we have the scientific research 1064 Raman spectrometers weighs 5.2 kilograms, and used the spectrum is also very good. So Raman spectrometers has applied to detect narcotic drugs, and it can detect the liquid safety detector and a plastic drug, pharmaceutical drug detector used to detect food safety, and the gemstone identification and plastic detector. And this is the fingerprint of, because the Raman spectrometer is the fingerprint of the material. So it's very accurate and detects a few seconds, rapid. And it just need to shoot a weak laser on a sample surface. So we call it non-detecting. And this is not involve any consumable accessory, just need charging. So it's costless. 1064 Raman spectrometers application, as we mentioned before, narcotic drug, pharmaceutic drugs, and also in food safety, gemstone identification, and some lab, tetra, archaeology, center apply to public safety. As we see that in the cars, if some passengers bring some explosive materials, liquids to the car, it will have a disaster. So it's needed to identify explosive, flammable, and hazardous liquids in the entrance of the metro, airport, BRT, concert, sports stadium, and large public places. We can have a court and jail, and we have police and firefighting essentials. I can just detect TNT explosives within seconds, kerosene, petrol, diesel, all these alcoholic, pesticide, all these materials are regulated, prohibited by the transportation systems entrance. So if we can use the Raman spectrometer to identify this passengers' bringings, take the things we can know this result. And this is the narcotics precursors. This is the police is arrest the drug dealer. Just need to have a ramen here to identify this is the drug dealer, and so he can in the field criminal investigation. Also, if he want to go to the factory to check any illegal narcotic drugs, so he can for narcotic drug arrest for customs entry and exit. Entry and exits, so it cannot. It's illegal to transit these narcotic drugs for the different before entering the country. So customs and armed police, border defense, fire brigade, and court and jail. Some people may curious why court and jail also need to use Raman spectrometer, because if some border people will not cannot be justified by the court decisions, the court judgments, and they can claim that if you we can suicide, we can he can kill themselves. They can threaten that if you judge me to the jail, and we will kill myself here. So maybe he can bring down some pesticides if he bring to the court. So the court will be threatened. In order to avoid such threatenings in the justice court, so it need to prohibit this pesticide or the drugs into the flowing access to the court. And also in jail, some criminals might suicide in the jail by drinking some pesticides to make a threat to the guarders. So, and the fentanyl detect is a very popular. Fentanyl is a police issues in China. So we need to just a few seconds to fast detect fentanyl, and we can have a few criminal check. And also we have a narcotic drug arrest, customs, armed police, and border defense. Raman spectrometers and has a material to analyze the application. And we have the police arrest drug dealers field. And we have a public safeties. We can have some drug screening online. And we have some customs in some customs and drugs liquid sampling test. Customers entry passenger fear inspection, and we have a call precursor later jail, and we can have an security inspect, jail entry security inspection, in pesticide drug or explosives, and we have big event security inspect in the entrance and exit. And a metro high-speed train and the liquid inspect, and all this defense, where can have the chances to use the Raman spectrometers to identify hazardous materials. And it's the 1064 nanometers Raman for narcotics arrest, like heroin and ice. This is 1064 ATR 6600 in the field to identify this. We call it Magu spectrum, because Magus compose at least 5 to 7% of ice. If you use 785, the spectrum is like this way, no peaks, no Raman signal at all. So if you use the red 1064, So the Raman strip is very obvious. And also heroin is also has no Raman signal by using the 785. If you can use the 1064, the dictate the the signal is very obvious. And also we can also have this chloroephedrine spectra, which have mentioned before. 1064 chloroephedrine signal is very good, but 785 has much weaker signal. And also 1064 nanometers Raman for narcotic detect like heroin and fentanyl. And this is the heroin and fentanyl. This is the different category, different types of fentanyl. And you can see it have each types of fentanyl have its vivid signals like this one. This vivid signals like this one, like this one, and also this one is different. And maybe this one, this one. So this vivid peak can tell the differences of the different fentanyl. 1064 nanometers can detect spectrums. The above spectrums can be detected by the ATR 3000 1064. So this is used our first generations of ATR 3000 1064 to detect the result. And now we have upgraded to third generation, and performance is higher, and signal to noise ratios have been greatly improved about 3 times. And the Raman spectrometers has been used to pharmaceutical. We know that for pharmaceutical drug production safety, for the purchase and production should be 100% authentic, and the FDA requires raw materials and excipients 100% factory in Spain. So Raman spectrometer are selected for this convenience, fast, accurate detect result, and compared to with the IR, FTIR, and the liquid chromatogram, and also European pharmacopoeias and use handheld Raman, introduced in 2016 April, also as PAT. And this is China pharmacopoeia. Introduction is published in these years. So compared to before, China pharmacopoeias has 10 times more pages, and for a Raman spectroscopy application. You see that in China CGMP, in article 106, all raw material and excipients should receive 100% inspection. And in article 110, ensure every package of raw material should be 100% authentic. And also in European and US pharmacopoeias also perform more strict regulation for this pharmaceutical drug and QA/QC inspect. Raman spectrometers advantages. there are three types of the technologies used for detect raw materials and excipients. They are HPLC. So HPLC efficiency high. Usually in pharmaceutical factories, there's a lights of the HPLC, and workers work to identify raw material, and excipient. And also FTIR is also used to identify and also we introduce Raman spectrometers for accurate and fast. So we can see introduce some advantage of handheld Raman is low cost. Raman spectrometer costs less. It has no sample preparation, so it's durable to use. And its size is smart, handheld, it's easy to operate. And it's only few hundreds of grams, and also it's no sample preparation, and its accuracy is stable. Just the fingerprint of the material is very accurate, and no influence by water vapor, and sample states can use in solid, liquid, powder, and organic and also dictate time so fast, take a few seconds and decades of seconds. So it's such fast. So all these 6 advantages has made the Raman spectrometers priority options for the raw material and excipients detection. And also we use the pharmaceutical industries of 1064 Raman spectrometers, such as we use the 532, 785, and 1064 to identify the acetaminophen. And we can see that compared to 532 and 785, the signal of the 1064 has the most distinct shape. So Raman spectrum can know material structure and ingredients and function group. So they are Raman spectrum of the material, and they are easy to detect and distinguish different pharmaceutical ingredients. We can see that this is the capsule, glucose capsule. This is the sugar coating inside capsule. And we can see the spectrum 785 have a big fluorescence background. If you use this is no peak. If you use 1064, the peaks appears in these areas. And so 785 Raman spectra shifts is hidden by strong fluorescence. It cannot tell the material. It can be caused some mixtures of the other material. However, if used with 1064, can fluorescence resist. So it has distinct shifts. Can identify, yeah, this is glucose peaks. So, and also we have used different 1064 Raman to detect pharmaceutical drugs. Oh, this is sorbitol, benzoate, and centers like this. And also I can compare the 1064 nanometers versus 785 nanometers Raman spectrum, like aminosalicylic acid. You can see 785 no peak, no Raman signal. However, 1064 has a distinct shape. And also lysine, no Raman signal, so 785. 1064 has distinct shape. And gibberellin, 785, no Raman signal, and 1064 has a nice spectrum. And
mebendazole 785 no Raman signal, and 1064 has a distinct shift, and omeprazole 785 no Raman signal, and 1064 has a very nice Raman signal, and salicylic acid no Raman signal 785 1064 has Raman signal, and omethine the hydrochloride. So the 785 has some Raman signal, but it's weak. You can see this peaks very weak. So very weak signals. And also we have a cycloparaxaramine, 785 no Raman signal, and 1064 had a Raman signal. And 1064 versus 785 Raman spectrum make a comparisons. We can know fluconazole and salicylic acid lysine. This is spectrum. 1064 next, we are going to introduce the 1064 Raman system used to detect pesticide. Pesticides used in agriculture to prevent disease and regulate the plant growth, forest and farming, environment and farming disease and make prevention. And in industry products like mildew and moss proof, there are many categories of pesticides like insecticides, acaricides, and rodenticides, and minerticides, and molluscicides, and fungicides, herbicides, and plant growth regulators. So they are not only provide food safety for pesticide residue and additive for gel and pesticide counterfeit. If some places use the counterfeit pesticides risky to plant growth. So we can identify the fake, inferior, and agriculture and forest, and also used in military backup and big event guaranteed. 1064 nanometer used to detect pesticide only system. As according to our experience, most pesticides cannot have Raman signals by using 785. So it's needed to use the 1064 Raman spectrometers. You can see paraquat, no Raman signal, 785. 1064 has Raman signal. And etorsazole 785, no Raman signal. 1064 has Raman signal. And also, we have a microbutanol 785, no Raman signal, and others have. And also, we have a glyphosate have some Raman signal, but signal is weak. The weak 1064 is better. And also we have a 1064 Raman spectrometers using the agriculture for the glyphosate, no Raman signal. And 1064 had a Raman signal. And pyriproxyfen 785 no Raman signal. 1064 had Raman signal. And also we have the ivermectin 785 no Raman signal. 1064 had Raman signal. And also spinrodin chlorphen 785 no Raman signal. 1064 had Raman signal. And this is the plastic ingredients. So you can see that 75, the peaks almost hidden by the fluorescence. Use the 1064, the peaks appears. And also used to identify plastic. This peak is very weak. And use 1064 peaks appears. And also this one, the peaks is not so good. If used the 1064, Raman peaks very nice. And these two EAV, EVA, and ABS plastics looks very similar, but quality different, price is different. So it's needed to use the Raman spectrometer to identify. So synchronous is some peaks loss, yeah. And if you use the by using 70 shifts are very similar. It cannot, these two is very similar. And also if you use the 1064, you can see very big differences of the peak. So these two materials can identify by the 1064 Raman. And also some dyes, stuffs, and pigments. The fluorescence is very big. So in like color powder, bound, glycerol, preservatives, raw candy, honey, bile, most pigments have fluorescence. So 75 difficult to identify, and 1064 can have a vivid peak. 1064 Raman applied to dictate fabric. This is the textile fabric. It's better, right? Polyester fibers we dye. So the blue one is the 1064 is much better. So this 75 no singleness. And also 1064 Raman spectrometer use biological samples. This is the embryo, the metabolin. You can see the 1064. The peaks is nice. So that's it. And next we are going to make a brief introduction of the OptoSky. OptoSky locates in these areas in the high-tech scientific research park. And we are in the 7th floor, 1, 2, 3, 4, 5, 7 here. We are in here, and the areas cover the 2,500 square meters. And OptoSky has 20 years developing spectrometers experience. We are the #1 Raman spectrometer manufacturer in China, and we have developed worldwide channels to sell Raman spectrometers. And we are the high-tech companies in China, and we are the national standard drafter. And also, OptoSky means opto and sky. And the logo springing indicates robust, marching, shining, and freedom. Upper orange indicates passion and innovation. Lower blue colors indicate stability and reliability. And this is the high-tech technology certificate. And our headquarters in Xiamen, Hangzhou, focus on manufacturing hyperspectral camera. And we also have Xi'an, Beijing, And this is the National Standard Drafter, China National Standard Drafter for Raman spectrometer. We are the hazardous material detector based on Raman spectroscopy. And also, we have a drafter of a Boyle type monitor of eco environment. And we have a China National Standard for online water quality monitor by spectroscopy. And we have China National Standard Drafter for water quality monitor in unmanned boat. And we are China National Standard Drafter for UV absorbent major fabrics. And this is the company certificate and patents. We have the ISO CE RoHS LVD, and we have this certificate. We have received IP standard certificate, and we have 20 patents for innovation, 32 patents for new utility design. We have 32 software copyright, and this is our honor awards. Okay, thank you. Welcome to questions. And we will end today's live broadcast. Thank you.